Hello, welcome to Chapter 1, Section 6, Modeling with Linear Functions Notes. Today we're going to talk about finding a line of best fit. The line of best fit is the line that lies as close as possible to all of the data points. And so if you see a scatter plot and you see a bunch of points, it's the line that goes through all of them the best. Now there's something called a correlation coefficient that determines whether or not that set of data actually represents a linear or whatever kind of function that you're trying to find. It's denoted by R and is a number from -1 to 1 that measures how well a line fits a set of data pairs. When R is near 1, the points lie close to a line with a positive slope, but it has to be 0.8 or higher. When R is near -1, the points lie close to a line with a negative slope, and that also has to be -0.8 or lower. When R is near 0, the points do not lie close to any line, so that means that you can't use that equation as a linear model. So we're going to do an example where I'm actually going to show you on the calculator how to do this. And you're going to make sure that you have all the steps written down so that when you get to class you can do it on your own. So the table below compares the average height of girls at different ages. Use the linear regression feature on a graphing calculator to find an equation of the line of best fit for the data. What would you estimate to be the average height of a girl who is 12 years old? So first we have to find the model, or the regression, or the line of best fit. And to do that, we're going to use the following steps. First, we will add, from the home screen, we will go to a new document, add lists and spreadsheets, input the data, label the columns, and then press the following. So you need to write that down so that when you get to class you can use it yourself. But I'm going to go ahead and show you what that looks like. So, here's your calculator. You go to a new document, add list and spreadsheet, and we're going to put our data in. Now you might have noticed that the data that you wrote down was horizontal, but you have to put your data in vertically. So we have to do the age in column A and the height in column B. So it's 2, 3, 4, 5, 6, 7, 8, 9, 10. You do have to make sure you put it in exactly the way you see it, or you're going to get something wrong. Alright, and then it's very, very important that you go up here where it has the little tag. Okay? Not where the equal sign is, but up there. And you're going to type in a word that represents what's going on. So it's age in years, so maybe I'll pick years. And it's height in inches, so maybe I'll pick inches. Then we're going to go to Menu, Statistics, Stat Calculations, and Linear Regression MX plus B. We pick MX plus B because that's the math one. Sometimes in science you'll see A plus BX. We pick our X list by just clicking on it and picking years. Our Y list is inches, and that's all we need, so we're just going to hit OK. Now right here, oops, you can see right here, M, B, R squared, and R. Okay, that's the equation of our linear equation. It's 2.516 x plus 29.56 b. Now we do have to look at this R. This is our correlation coefficient. It is very close to 1. So like it says in the notes, you have to have 0.8 or higher. 0.997 is higher than 0.8, so it works. So this is a linear regression. So we're going to go back and look at we'll actually answer the questions. So when I write this down as an actual answer, it would look like this. Y equals our M from the data, which was 2.516 x plus our B, which was 92.56. Now if I wanted to estimate the average height of a girl who is 12 years old, all I'd have to do is plug in 12. So Y would equal 2.516 times 12 plus 92.56. Okay, we'd put that into a calculator and it would give us a number, and that's it. That's what we're doing. So make sure you have all these steps written down very clearly because you will be using them. And if you don't have the steps, Well, you need the steps. Have a good day.